one of these, I can download them. I already have them up here queued, so I can run them and share my screen. But even that doesn't give me share screen. I'm going to leave the room. On-site tool, full client with video. That's what I did wrong.
You used that one?
Yeah.
I used the other one.
Well, yeah, because you don't need everything. See, now it's asking me for my permissions. That makes sense. I came up like, wait a minute, I'm just in it. Perfect. All right. Now I've got them. See them all? Okay, share slides.
Okay, perfect. There you go. Bottom, I guess. In the bottom, no? No, select slides. Go back. Click on it, yeah.
Oh, it's hidden down here. Boom. And only a minute late. Welcome to BIER. But Jeffrey's not even here. All right, so we're post-lunch, which is usually tough. It's the nap hour. So we'll try to make this as exciting as possible to keep everyone from falling asleep. I'm going to wait a bit. Go to you, all right? I just wait people roll in.
Start jackhammering, so maybe speak more into the mic. Might be better.
I am your father.
You have a lot of slack on it. It has
Great.
as comfortable as close to it as possible.
Hey world, here I am. Nice of you to join us, co-chair. You're 2 minutes late. 2 minutes and 15 seconds late. I've been here for how long? Like minutes.
Yeah.
Waiting for
Whatever
you.
the man said, he had no executive power. Okay.
You did have like a small drama.
Oh yeah, well that's.
I logged in as the on-site tool, but that's not what you need. You need like the full permissions tool, which is
I
different.
didn't even
Screaming
look.
your name.
I didn't. Like, you don't need to give him ammo. He makes up enough crap to be mad
God,
about.
now 2 stand-up commissions beside me.
There we go.
Comedians beside me in this room.
All right. These are the people I was waiting to show up. Perfect. So let's leave the door open because people are still coming. But you know what? Yeah, it's not that loud out there anyway. Normally I shut the door because it's just crowds of people, but this isn't bad. We'll keep them invited in. Welcome to BIER. Welcome to Vancouver. I think you got some other groups as well. It's fairly light, but I think there's some interesting bits. I will dive right in. Note the wellness. Everyone noting? Look, I see people actually looking up. Yesterday at M-Bone D, it was like just, I don't think Stig ever looked up. More noting, really well. All right. Tips. Everyone use a site tool. We know we're blue sheets anymore. Scan the QR code and it just, the magic happens. Same thing with hands. I mean, it's not a big issue with the people in this room, but we do have remote participants. So use the Q tool and then I can manage them and keep the chaos to a minimum. And simple, agenda prep. You guys have been on this page, but it's up here in case you're just stumbling into your first working group meeting for the week. Agenda's light. Just some update status, some conversation updates to give you guys on charter and milestones as well. We've got Jeffrey presenting twice. No, Tony's going to do the first one. It's just the draft is after Jeffrey. Yeah, if your shadow is on the QR code, it's no longer a QR code.
I thought it's redundant. Wait for shadows. No?
I'm here for you, Tony.
Lousy technology.
And then BIER Michael Loop after. So that's only 35 minutes, 50 including me. So, all right, we got another Jeff here, perfect. So charter and milestones. If you look at our milestones list right now, it's rather updated. There's no milestones actually on it from a temporal perspective. They're all accomplishments. They're all old dates. And additionally, we didn't have a lot of structure around the milestones at that time. Each working group kind of did their own thing. And it was actually a list that I sent to the AD and then we sent it up and it got published. Now there's tools around it that we can edit, and most of it's just me clicking buttons. Anything new, the AD has to approve. We banged on it a little bit. You might have seen the email when I deleted an item. Apparently, email sends out every time there's a change. But if I set my schedule correctly, I can change them all at one time and minimize the amount of email. But that's just a warning. And the charter is just some minor updates. Oh, wrong button. So the recommendation in talking to Gunter is like, these aren't milestones anymore. They're all accomplishments. We're going to delete the whole list and we're going to start with something new. And for archiving our accomplishments, we can put them in the archive. And what was suggested is itemize a list of accomplishments, maybe, 2 or 3 of those blocks to say how we've gotten to where we are. And then add all the open drafts to there. We have the option of not having a date on the milestones. And I think it's fair enough, at least take a temperature of the room. You guys have been paying attention to milestones at all in this group or others? You see there's like projection dates of when things are going to be accomplished. But if you've been in the IETF long enough, you understand that everyone's here on a volunteer basis. It's usually a side job from our full-time employee. And you can't tell anyone else how to manage their time. The best we can do is encourage and contribute as best you can. So there is an option to not put dates on the milestones. We'll just have them up there as targets. And that way we don't have someone down our neck if we're late on something. We're just trying to move things along. Anyone opposed to removing dates from the milestones, please raise their hand. Not one. Should I do, let me chat open. All right, got that. Isn't there a show of hands tool? I'm going to title. Now I'm going to go to the positive. Remove dates on milestones. Who likes the idea of removing the dates on the milestones? Raise your hand. There we are. Okay. We have some listeners here. You're supposed to act, let's see, I'm going to start it, and now we can do this correctly. There we go. All right. Please give your input to the hand tool. Did you do it? Oh, you have one thing to do.
Yes. I was listening, how you make yourself king without any limit, on your executive power. Any time limit now.
It's baby steps, right? It's the boiled frog.
Yep.
All right, looks like we got fairly unanimous in the room. I can take the list. I don't think it's something that's that critical, but at least keep it transparent, let people know. I'm gonna terminate the show of hands. Thank you so much. So we're gonna add all the open drafts, and then reading the working group guidelines draft. There is some verbiage in there about the milestones kind of falling out of the charter. So if there's things we need to be doing, at least chartered things we should be looking for, and they're not open drafts already for them, it's appropriate at least to stick it in the milestones. Yeah, this is part of our charter expectation. We'll put it in the milestone. And once we have a draft actually attacking that work, then we can make that update at the time. Okay. On the charter, if you read the first paragraph, our most recent charter, which has been revved a couple of times, it itemizes our encapsulation accomplishments, architecture accomplishments, kind of original objectives that came from the BOF and the instantiation of the working group to begin with. Some things have been added since then, haven't been added to the charter itself. We have an ether type assignment, which is fantastic. And actually that brings up a really good point, because I think it's the IEEE record doesn't have the RFC number listed. They have the old draft, and there's some expectation from the IETF to make that request. And I couldn't do it because I didn't make the request for the NCAP or the ether type. So there's actually a thread where I was working with Alvaro. I pointed it out to him, made the request. He was going to fire it up the tree, and then Alvaro walked away, and now it's still there. So it's just a housekeeping bit.
Yeah,
but
Aliyah did the original thing with me, right?
Aaliyah submitted it, and we got it back, and then Aaliyah stepped down, and Alvaro came in, and that's when I saw IEEE had made the change, and that fell into his hands. The other thing is I think should be added to the draft is we have an objective of finding a V6 encapsulation solution. We've done it. We've already adopted the draft, And so I'd like to remove that as an objective and add it to an accomplishment. And some things, in fact, you might want to elaborate on these because you had some input on it, but to expand the objectives, instead of removing stuff we've already done, put in the accomplishments and adding some objectives that have been coming up along the way. Wow. Okay. Oh, this?
From outside.
Oh, is it really?
It's not even from the hotel.
Wow. Yeah, then nothing they can do about it then.
So they're
All right.
moving before they tear the place down.
I can actually ask to be on the voice.
Yeah, crazy. All right, so
Construction workers, tell them there's free beer in the bar. They'll immediately stop.
or just come out there with beer. We'll sit down, it'll be done.
Right, that will be it.
So one thing that's come up is some solutions around large fan out, some potential increasing replication and coding efficiencies, maybe a rev and beer. These things have come along, and I think it's a safe charter objective to say that we're open and looking for ways to continue to improve efficiency and scalability of beer. So that's an obvious one. Other thing that's come out probably, gosh, in full force back in Prague, and there's a lot of churn in Brisbane about it as well, is all this work taking place specifically for network requirements for AI-like data centers. And if there's a multi-point requirement that index replication makes sense, I think makes sense to have that in our charter as well. So again, we don't have an active draft, but it's something to say we are here. You want to work with people who work in replication space, we can help. And the last was something Tony brought up, was like in substrate computation for replicating fabrics, where nodes are actually doing some intelligent, what you were talking about, multiplexing in some way, wasn't it? Muxing up the tree. So again, not specifics on there, no solutions, but we're here as the experts in the replication space for indexed packet-driven fabric. So in terms of process, the charter will be taken the list. I've got most of it written. So in the next week or two, fire it off the list, we'll get response. And I think from there, Gunter, does it go up and you have to get approval as well? Okay. Gunter will do his magic. He's got all that AD magic superpowers. I saw he's got buttons that I don't have. He can actually click things that I can't click. It's amazing. What's that? Oh, he does. Close working group is an actual GUI button. That's hilarious.
Don't play with too many buttons before we have to unwind the damage.
Yeah, can you unclose?
Wait,
Remember Gromit
no,
trying to pick the button back up? Like, oh,
no,
shit.
he does stuff like that. We just ask for one button additional on top of our thing, which says fire AD, and we're good.
We don't have that button.
We don't have this button.
Oh, man. Milestones, from what I understand, don't require any really approval up the tree, but I'll keep you guys abreast of the changes. And there may be some email churn. It's just notification stuff. I'll try to keep it to a minimum. Drafts. We've made some great progress. It doesn't always feel like it, but considering the previous two IETFs, we no longer looking for shepherds. We have shepherds assigned and documents are moving. We've got BIER VPN in the ed queue, which is pretty darn exciting. We've got drafts in the ISG and some that just got submitted. So the OSPF v3 extension now, I guess it's expired. It needs some comments addressed from an AD in April. So I don't actually have the thread or the author on that, but something we should hunt down.
What's the OSPV 3? That's been
Yeah.
going on forever. I poke people 10 times.
You can't just sit back and act like this is your room, brother. You got to talk.
Well, you look so competent. Yeah, so the OSPV 3 has been going on forever. I mean, I poked the authors about 3-4 times in the Shepherd and so on. And I think we're not there yet. So what can I do?
All right. We've got Tether on 80 review, and we've got a new version that address some comments for BIER IDR. So if you're on the list and you're participating, please engage and let's move these along. Now we've got past working group, or actually looking for feedback for 3 drafts. So LSR working group is reviewing our non-MPLS extensions. SR and IDR reviewing LS BIER. and then VGBLS BIER. And then we've actually had some really good feedback, even the last couple of weeks, addressing some of the questions on BFD. Thank you, Bless. I really appreciate that. And Greg, I think, had a good thread going back and forth. So it looks like that's making progress, and it's very encouraging. We have some that's passed or in. So director review, waiting for a shepherd, director review, and shepherd review and shepherd assigned. So none of these looking for shepherds. Thank you all who have stepped up. These moving along. I think a couple of these, like shepherd review done in BIER and 6. That's probably just a button click at this point, is it, to publish? So we can get that moving. Yeah, I think we just go in the data tracker, change the state of it, and then it does a submission. All right. Thank you so much. On to the fun.
Thanks, Sandy, for all the excellent bean counting and keeping all the status. And don't be afraid. I mean, I had people this time poke me, right, when the stuff sits for too long. Sometimes, you know, the chairs just sit on the stuff and you have to be the squeaky wheel.
We're going to give acknowledgments. I want to thank Sandy personally for putting up with Tony. This is amazing work you've been doing. She can't even hear. I'll just talk like this. We'll just talk in binary. Okay. So first up, Tony is going to be presenting. Do you have your clown shoes and hat? No?
Yeah, I have clown shoes.
Okay, there is a close this thing somewhere, stopping slides and adding new ones.
So if you're absolutely shocked that I'm so well dressed, Lufthansa lost all my luggage.
And this is BIER, isn't it?
Yeah. Is it a compliment? Then on the other hand, you know, you as fashion critic, keep your day job. All right, I just walked in one store and bought everything I could find. That's pretty much my strategy. Anyway, so let's get technical. So the problem has been kind of tackled by a couple of people before, right? Toles was showing you up with some stuff. There were a bunch of suggestions, the Tübingen guys. Is the problem real? Yeah, starts to pop up. So when I was thinking about the stuff with a bunch of other people, you saw the authors, kind of, you know, there was a little bit of soul searching behind the scenes. And the suggestion is, so what's the problem, right? The problem is that if you run a BIER of a very large BFR ID space, so like 60,000 servers or something, and you have a problem that always, you know, to progress, an algorithm addresses just few receivers, relatively few receivers, but they always change where they are. Examples are MapReduce or rate striping or actually distributed elections and locking on databases. Hierarchical distributed locking has the same properties, funny enough. I know it's not here, but it's kind of, you know, something I pay attention to. So we can degrade into ingress replication. So the simple example below is that we have whatever, you know, 4 sets on the whole space. And we have 2 receivers. And if you look, what are the all possible permutations, actually, where 2 receivers may end up in. So both may be in the first set, or 1, 2, 1, 3, 1, 4, right? You have about 10 permutations. And when you look at when you hit ingress replications, you hit it when you have 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and so on. So 6 times, which means you have a 60% chance with 4 sets and 2 receivers to actually end up in ingress replication. And if you look at 16 receivers, which is roughly what people talk about, and we talk about 65K BFR ID space at 256 bit mask, and if you do some permutation math, you end up roughly with 0.4. So it's 40% chance of ingress replication. That is fairly serious. Next one.
Oh, next slide. I'm just hearing them louder than you.
We won't let them in.
Go bing!
Yeah.
Like a slide step, you know, like 16 millimeter.
So for we think there is a relatively practical solution that will cost some hardware, in terms of delay, but it's relatively easy to implement with existing silicon as an intermediate stage, roughly. But there's more advanced stuff, but I'll talk about it later. And basically, what we would do, we would take the 256-bit and chop it up in 16-bit to address the BFR IDs and treat it as a sequence of BFR IDs, right? And to make it really simple on hardware, we allow replication. So the same BFR ID may show up multiple times, but it means only one replication. We allow basically invalid BFR ID anywhere, right? So when you replicate, you can actually, modify this, what I call unmasked BIER or UBIER bit mask. You can modify it, easily. And the BFR IDs are not sorted because, this leads immediately to silicon problems. And the signaling is really simple. We basically stick one more label binding, but this time, of course, there is no set binding, right? So this is basically one label for an MTSD BML and carried around. So fairly simple stuff, right? So on 256-bit bit mask, you basically stick 16 receivers. You have more, you need 2 of those packets. Next one, please. So once we start to think through the stuff further, couple of interesting properties emerge, or design decisions we would have to take. And none of this stuff is kind of, like stood up or done in silicon. Clear disclosure. This is like initial ideas after chewing a little bit with customers and a bunch of people who have been involved in BIER since a while, plus talk cautiously to a bunch of silicon guys. So we could mix UBIER and standard BIER mask, even the same subdomain, because we have the label binding. So we actually know when the stuff arrives, what is the decoding of the stuff. However, right, someone in the middle trying to decode BIER now really has to understand what the bit mask signifies. We already have to an extent the problem today, because you have to understand which set a specific BIER packet belongs to, but this kind of multiplies the problem because all of a sudden the BIER mask has 2 different semantics. Simpler thing is that the UBIER subdomain could shadow a normal BIER subdomain, right? So we basically run subdomain which is congruent with the normal BIER domain, and you run UBIER on it. And in those cases where you have very few receivers of a lot of sets, you basically send a UBIER. Sequencing is, of course, a consideration, right, in such scenarios. There is also the possibility, well, if you have like such shadowing subdomain, of course, you start to think about compression and decompression, by which I mean that, let's say you get 2 normal BIER packets for 2 sets with 1 receiver. You could send 1 UBIER packet to the next guy, basically encoding the 2 BFR ID and reduce the volume by 50%. This is harder than it sounds because you have to somehow buffer frames, right? You have to take the first frame, wait for the second, and if it makes sense, you send UBIER, otherwise you go, oops, okay, I delayed the first frame for no reason. Now I'm keeping it really simple, but also an architectural consideration. And what this does not address, as Jeffrey pointed out, is that it is not even, also let's say, at the source, we address the problem now well. We don't generate 16 frames. However, if we don't control the replication point on the fabric, the next node will actually generate, 16 branches. So the problem of how do we control the replication points on the tree, this thing does not address as it stands. So, which something like this compressed tree proposals, which, they still struggle, with what they want to be when they grow up, adopted or not. These things were kind of including it implicitly, or not. Next one. I think that's it. Mm-hmm. I think that's it. So discussion welcome. Further considerations. Stuff hangs there. as a proposal. Thanks.
Are you looking for adoption?
I think it's too early to ask for adoption. I'll kind of stew it for a meeting or two and see whether stuff pops up, right?
Justin Sir, NVIDIA. I'm highly in support of this draft. There is another use case that Tony hasn't configured that's related to AI space. The MOE specifically, or mixture of expert, which is the kind of main way to distribute traffic.
Expand the acronyms, Jeff.
Yes, I'm doing it.
Good.
Mixture of expert means that a model during training will choose a set of experts to do the training. In multimodal models, so multimodal means it doesn't do only text, but also pictures, anything really. The only way to do it properly, you need to choose different experts in different parts. And it seems like there's a need for new operation called shuffle. Shuffle is kind of limited all to all, but limited to group of particular GPUs. And it's determined pretty much within number of microseconds before you send the traffic. So there's no time to signal anything over a GMP. So practically, the only way to do it properly is to encode it in data plane, which is what BIER is. The problem with it, application layer doesn't really know who shares same domain in terms of BIER. So doing this might alleviate this problem and kind of reduce, as Tony said, risk on ingress replication. Otherwise, it just becomes one big screwed up. If you need to replicate every time per group of.
So two demands: write some text, and then we slap you on the others or something, and find us $1 billion out of the coffee jar in NVIDIA, and then stuff will happen real quickly.
So it's been looked into. I cannot tell the names, but practically, if you're large enough, you develop LLMs and you run the stuff at scale. That's something you would be looking into.
Yeah. So because from the silicon side, it's not hard to build. It will add some delay, right? The compression, decompression is tricky business. Not even sure whether it's worth pursuing, because if the application really runs on the subdomain, has relatively few receivers, that compressing the stuff doesn't make much sense. You control it at the source. Silicon, most straightforward implementation. You take this thing, you translate it literally into set lookups. You do the lookup, you get the stuff back, and you basically take the bit mask and the set lookups, and you write out the bit mask like that, the UBIER bit mask out again. And all these things, like I said, or you can just basically replace it with a 0, or you have duplicates and so on. That seems to make parallel silicon operation much more feasible than waiting for all the results and then actually muck around with the bit mask. So yeah, okay. Text would be appreciated, even if it's just 3 sentences, and we chuck you on, and I would say we let it sit for a meeting or two. More discussions, possibly, like you say, with the LLM guys, and yeah, then maybe we call for adoption, unless there's some major objections or problems pop up, or another alternate proposal, which is somehow more practical. Goodie.
So at this time, no vote. Yeah, I've got contribution to add, jump on the authors and throw things at them. Mud sticks to walls. See you, Jeff. All right. We've had enough of you, Tony. That's your last slide. You can whiteboard something else on the screen if you need to. It sounds like you just
I can make up a stand-up routine, watch enough Seinfeld.
Do you know any
okay,
poetry?
let's leave with Jeff. And now for something completely different, I guess.
A man with 3 buttons. Next is brownfield deployment.
Hey, good afternoon. So this draft and this presentation is about brownfield deployment options. It's an informational draft. It's actually renamed from previous drafts from many, many years ago. It was called migration options before. Figured that brownfield is a more accurate word here. Well, mainly talking about how you mix the BFRs and non-BFRs, not necessarily the migration paths. Next slide, please. So yeah, brownfield deployment is basically when you have mixed beer routers that and beer incapable routers in a beer domain. Um, there are 6 options listed here. We'll go through them one by one. Next slide, please. The first one is we call it naked multi-topology. It's basically that a separate topology that only includes beer-capable routers and the connections between them. Those connections can be native links, or they can be tunnels. But those tunnels do need to be viewed as IGP adjacencies. When you have that, then we do not need any protocol extensions. We just use IGP multi-topology and existing beer signaling, everything will just work. Next slide, please. The next one is spelled out in section 6.9 of our architecture spec. Basically, at the end of the SPF calculation, we will try to figure out which of the children's of the root do not support beer. We go through every of those children, and then we replace a child that is not beer capable with its children, and basically reparent its children to the root. So now a beer incapable child of the root is removed from the SPF tree, replaced by its children, and reparented to the root directly. Eventually, all the children of the roots on the SPF tree are beer capable. Some of them are reparented ones, and they must be reached via tunnels. And so now you just do either native forwarding or tunnel forwarding to the children. This concept of tunnel to downstream BFRs can be achieved with BGP signaling as well. This is done with the BIER next hop in the BIER attributes in the BGP signaling. That BIER next hop is only changed by the BFRs. So I'll skip the details for the BGP case. Next slide, please. Another option is to skip non-BFRs or BIER incapable routers in BIER specific calculation. We basically run separate calculation for BIER purposes. We do need to signal a BIER algorithm value in the IGP and that value indicates that we are not going to use the unicast SPF. We'll do a separate BIER specific calculation. And in that calculation, when we realize that a router does not support BIER, then we do not consider that router at all. To do that, we need a simple protocol extension to signal, to define a bar value that indicates the separate calculation. We also need to make sure that we have complete topology that connects all the BIER routers, either with native links or with tunnels that can be viewed as IGP adjacencies. Next slide, please. And then we can have a guardbox controller that figures out everything and just tell every BIER router how to forward BIER traffic, whether it's native BIER forwarding over between directly connected BFRs or using tunnels between them. Next slide, please. Another option is tethering. All previous options could lead ingress replication like tunneling. If you look at the picture in the upper right corner, we have BFIR, the ingress router on the left, and we have BFERs on the right side, and we have BFRs 1 through 6 in the middle. Right in the dead middle, there is a box marked as X, which means that it does not support BIER. In this case, the previous options we talked about will likely will cause the BFR1 to send 4 copies, one to BFR3, one to 4, and so on and so forth. Basically, on the link between the BFR1 and X, we will have 4 copies of the same traffic. And that may not be desired in certain situations. For example, there could be a long haul transocean link between a BFR1 and X. We would like to avoid those multiple copies there. Tethering can avoid that. It's depicted in the lower right corner. Basically, we attach, say, a small BIER router next to that router that cannot do BIER. There is, because they are next to each other, we can have a local fat pipe between them. And then the BFR1 will only tunnel 1 copy to that tethered router BFRX. And that router will then send individual copies to BFR3, 4, 5, and 6. So you avoid the multiple copies on the link between BFR1 and router X. And this is as if that we turn that X into the BIER capable by attaching an external router to it. And the signaling for this is actually very simple. And the concept also works with BGP signaling, but I'm not going to go into details of the BGP signaling here. Next slide. All the solutions we talked about so far assume that the flow overlay edge routers support BIER. For example, in the case of MVPN using BIER as underlay, and we would need those MVPN PEs to support BIER and capable of BIER forwarding. In a deployment scenario, you may have a situation where most of your important replication P routers can do BIER, but many of your edge routers cannot do BIER. In that case, we can do PHP, penultimate hop popping. The BFERs, in this case, the MVPNPs, they can request its upstream router to pop the BIER header so that the BFERs, they do not need to handle BIER forwarding. In this case, the BFERs, they do need to support the complete BIER control plane, including the overflow overlay control plane, and they also need to request to do PHP, but they do not need to handle BIER forwarding. But on the other hand, if you have an ingress PE, they need to send the multicast traffic, then either that ingress PE needs to be real BIER routers, they can do BIER encapsulation, BIER forwarding, or the ingress router will have to send traffic to another router who can do the BIER encapsulation. But here the main benefit is that the egress routers do not need to handle BIER forwarding. Next slide. So this is a summary of the brownfield deployment options. Naked multi-topology, section 6.9 of the architecture document, and its BGP equivalent. You can skip the non-BFRs in the BIER routing table and BIER forwarding table calculation, and you can use controllers to program those forwarding tables into BIER tethering, and finally you can do PHP so that your BFERs do not need to handle BIER forwarding, they only need to do the BIER control plane. As far as I see it, the most practical solutions will be the section 6.9 of the RFC 8279 and the tethering and penultimate hop popping. The other solutions where we skip the non-BFRs or using the naked empty, that can be done. It's just you need to make sure that you have the complete graph of the BIER routers. Especially, you may need to use tunnels that can be viewed as the IGP adjacencies. And that part introduces some operational complexity. Next slide, please. So basically, all these options have their corresponding specifications. The purpose of this draft is just basically informational draft to list all these options for the operators and vendors to consider these options and what's the best option for them to deploy to development. So we'd like to invite discussions, comments, and eventually maybe a working group adoption as an informational draft.
Got one question?
Whoops. I think there were a couple of more drafts too, right? For brownfield, wasn't there like a PIM signaling over BIER, MLDP, over BIER, IGMP, and all this stuff for the brown? Like I think those become very useful for the vendors to stitch multiple PIM domains or MLDP domains and stuff like that.
Okay, so I think you're talking about how to do multicast forwarding end-to-end, where part of it uses PIM and part of it uses BIER or something like that. Is that correct?
Yeah, so I think when we started, multiple vendors, they were giving us feedback that they do like BIER, like let's say like in a 5G network or IPTV, right, where you have these legacy routers at the end that are doing PIM or IGMP or even just MLDP, and they were saying that, well, I want to go in a clean core that IGP underlay, BGP overlay, right? And I want to deploy BIER in my clean core. So how do I stitch my PIM? So that's where we came up with the PIM signaling over BIER, MLDP signaling over BIER, which I think I need to ask for a last call on that one, actually. So we came up with 3 drafts that were grabbing this legacy multicast stuff and kind of signaling it over BIER to the other end, right? So I think for brownfield, those would be obviously useful, right?
Okay, I see your point. Indeed, when this draft was written, we were more focusing on that in the BIER domain itself. What if you have the routers cannot support BIER? Your point is that end-to-end multicast where you can have PIM or some other forwarding in some part of the network, and then you can have BIER forwarding in some part of the network. I think that's a valid point. It is indeed a valid point. It's just that it was not in the considered in this draft initially. We can either include that in this draft, or we can do another draft in the MBOND. I'm open to anything. Yeah.
Well, I mean, my 2 cents is if you have a draft that you want to give to a provider just to deploy BIER anywhere in their network, one single draft would be ideal, right?
Sure.
Yeah. Agreed. Question, Human. The problem when that ended up at the end was that if you had multiple ingress into a BIER domain, right, we needed the election of the replication point. You remember, because of the redundancy. So did that make progress? I think that went to PIM to be worked on.
Yeah. So in PIM we did PIM Lite. Sorry, what was the chair? What was the director name? I forgot his name. I'm horrible at names. Not before Gunter, there was another one, and then the one previous.
It was Aliyah, Alvaro.
Andrew.
Who?
What's his name? From the African.
Andrew.
Andrew, right.
No. After Andrew. Anyway, there was a. No. This guy's good. He's good.
There was no one between
two directors before. So Gunter, there was another gentleman, the one before that. Anyway.
Alvaro.
Yes, that one. So he was saying that if you are doing this funky thing with PIM, go to PIM and come up with PIM Lite. So PIM Lite is becoming RFC anyway.
I think that's Alvaro.
That's done. So what I'm going to do is now I'm going to grab the PIM Lite, bring it into the PIM signaling over BIER into that draft. So finish that draft with PIM Lite in there. But then there was a MLDP signaling that I think, ICE, Jeffrey, everybody was on it too. Again, same idea. If you have two MLDP islands, and you want to connect it to a BIER core, and then I think a stick put another draft for IGMP
Yep.
being a stitch over BIER, right? So all this stuff are brownfield to me, which I
Yeah.
would imagine having it in a single draft.
It's
would-
a good idea to cover that. Is basically flow overlay part. It's good idea that we have that covered as well.
Okay,
It's
thank
just
you.
at this moment, this draft is indeed only for the BIER underlay. Yeah.
Okay, so just to ensure, do we have agreement that we're going to cover it in here, or do we want a different draft?
I'm fine with covering.
Okay, let's
here.
cover it
Yeah,
here. All right,
yeah.
cool.
But Human, my question was, there was one piece missing. If you had, let's say, the same PIM domain hooked up to a BIER domain at 2 points, right? We need an election algorithm for the replicator.
Yeah.
Which one? And was that work ever finished? Because it kind of wandered out of BIER because it was like generic for a lot of protocols.
No, the election work was done. The election
Uh-huh.
stuff everybody agreed on
Yeah.
in the working group. The only part that the director didn't agree on is the fact that we were trying to come up with a PIM specific protocol that didn't have hello.
Yeah.
Didn't have PIM hello, because we said there is no PIM hello. And he said that, well, that since this PIM doesn't have hello, it's a beast of its own. So go work in the PIM working group to
Okay.
come up with with a new protocol, which we call it PIM Lite. And now that that's becoming RFC, I'm just going to grab and push this into this other draft in the
Okay.
BIER side, and then the work is done. The work was done.
Okay, so we basically have this PIM unicorn dancing by the stream, but we'll have a generic
Yeah,
solution for everything else.
He just wanted me to do more.
Because that's the missing piece. Okay, and then, yeah, I mean, you gentlemen discuss. One
Yeah.
draft sounds good. On the other hand, it becomes, a huge kitchen sink. I don't know. I'm
Yeah, I mean, if
agnostic.
there is another draft, I'm okay with that. I can start another draft, but I would imagine, if you want to, I would join this draft too and just put it into this draft so we have one draft for everybody.
Yeah, we can work on the content.
Okay,
Yeah.
thanks.
Okay.
Right. I mean, if an RFP goes out, I tend to agree, right? The less RFCs they have to stitch together to actually get their heads around, the better. Sure.
One more point about the election, so that we don't send traffic redundant traffic into the BIER. That is actually okay. When you do have 2 entry points into the BIER domain, the BFER, one particular BFER should only be should only be receiving traffic from one of the entry point anyway. So it may not be that efficient, but there should be no problem of duplicate traffic arriving onto the same egress. We can follow up on that.
Yeah. Okay.
So adoption. Here's read the draft. Some people, all right, I'm going to set a vote for adoption, test the temperature of the room, and then of course, let's go to the list after, but break up your app. We need a song that plays right now, kind of like in Jeopardy music right now. Is someone looking at the phone?
You're not good looking enough for
Dun,
Jeff.
dun, dun, dun,
Here we
dun,
go.
dun,
Perfect.
dun.
Thanks. I need to have that queued up. I can just play it here.
Doesn't show up. What's going on?
By the time I get it up, it's over.
Unstable connection to the server. Thank you. Thank you very much. Yes.
Now that we're not talking, the noise has gone away. How nice of them.
Yeah. Check whether anybody's sticking minutes, maybe.
No, we got the going.
Oh, yeah, that's good. Yeah, I don't see the poll.
Voting. Everyone voted?
I don't see.
All right, excellent. We show 5 support, no dissension. Check the list. All right, next slide. BIER loop avoidance using SR. Is this remote or do we have? It's not me. There we go.
Hello?
Gotcha. So do you want me to, you want us to run the slides yourself?
Can you help me to control the screen?
So if you just go down below, there's a share slide icon. It's like kind of grayed and slashed out till you put your pointer over it. It'll say share slides. Select your deck and then confirm your selection and you are in charge.
I can see the screen.
Share screen, slides, either way. Yeah. We prefer share slides because we know it's the copy that's been updated and uploaded.
Can you help me to share the screen? I can see the share screen.
Looking for share slides.
I can hear the share slide. I can hear.
Okay.
I can.
So I can run the slides for you. Just tell me when to change them.
Oh, thank you.
All right. There you are.
Hello everyone, this is Yuan Chu from New Edge 3C Technology. I will present a method of use segment routing to avoid a micro loopback in BIER forwarding. This draft was presented at the IETF 180 meeting. For the comments, we have updated the draft. Today, I will further introduce the scenarios of microloop, as well as the problems that still exist when applying unicast loopback avoidance technologies. Next slide, please. Thank you. We use this finger to introduce the loopback of BIER. The initial BIER forwarding path from R1 to R9 is R1, R2, R3, R4, and R9. Assuming the link between R2 and R3 fails, the process is as follows. First, R2 perceives that the route to R3 is unreachable. Before the route convergence, FR take effect. So if BIER FR is enabled on R2, R2 will send packet to the backup neighbor, R6. Let IGP publishes the link flow event within the domain. Each node recalculates the route. After that, they update the Faber and BIER forwarding table. From this moment, the old FR backup path is no longer effective. After R2 complete the route convergence, the BFR neighbor from R2 to R9 is modified to R6. But if the convergence speed of R6 is slower than R2 during the route convergence, because R6 neighbor to R9 is still R2, so R6 will forward the packet to R2 again. There will be a short-term loop back here. Next slide, please. During for recovery, there is also a loop, as shown in the finger, a link flow account between R2 and R3. After route convergence, the BIER forwarding from R1 to R9 is changed to R1, R2, R6, R7, R8, and R9. When for recovery, if R6 route convergence faster than R2, R2 will still forward the packet sent to R9 to R6. But on R6, because the BFR neighbor to R9 has been updated to R2, so the BIER packet will be sent back to R2. there is another forwarding loop. Next slide, please. If BIER use unicast micro loop avoidance, packet will be forward along micro loop repair list, but there still may be loop during the root convergence. As shown in the figure, there is a link flow between R2 and R3. All nodes that perceive topology change will recalculate the SPF tree. After root convergence, R1 as PLR will establish a microloop avoidance tunnel and start a waiting timer of root convergence. During the timer, if R2 receives a packet to R9 and R10, it will forward the packet to R6 through the tunnel. On receiving the packet, R6 first unpacks the tunnel encapsulation and search the BIER forwarding table to determine the BFR neighbor to bit 10 and bit 9. If the root convergence of R6 is slower than R1, on R6, the BFR neighbor of R9 and R10 is still R2. So R6 will send the packet back to R2. A loop appears between R2 and R6. Next slide, please. This is our proposal. Take R1 as an example. When R1 perceives topology change, it processes as follows. Step 1, R1 recalculate the SPF tree based on the new link state. Step 2, R1 utilizes TI-LFA to calculate the PQ space for leaf nodes, which perceive topology change and establish SRMPLs or SRV6 tunnel between PQ nodes as a loop repair path. Step 3, after completing the root convergence, R1 start a waiting timer. During the timer, R1 forward BIER packet to R9 to Q node through the repair list tunnel. Q node unpacks the tunnel encapsulation and copies the packet to leaf nodes R9 and R10 according to the local BIFT. After the timer expires, R1 will forward the packet according to the updated BIER forwarding table. All BFR within the BIER domain perform the same process as R1. Next slide, please. This is the methods of establishing SRMPLs or SRV6 tunnel for BIER loop. Currently, we have come up with 3 methods. Method 1, BFIR establishes an T path which is forwarded through BFIR P node and Q node. Method 2, BFIR establishes a B path between the repair node and the Q node. Method 3, this is a preliminary method. If there are multi-leaf nodes share the same PQ nodes, we can consider establishing a P2MP repair path to reduce the packet replication at the intermediate nodes. Q nodes act as leaf nodes. Next slide, please. This is our proposal. Welcome any questions or comments. Thank you.
Comments? Okay, so chime in. I don't want to be too discouraging, but since the whole work is relying on IGP anyway, looks like the unicast variant is basically remote LFA on the fly, which will be much slower than if IGP already has RLFA set up, which gives you the same protection without any delay. The proposal of actually protect with the point to multi-point tunnel is intriguing, but I do not understand what kind of a point to multi-point technology we would use there to protect. So that's something I can grasp my head around, because that's something IGP couldn't do. So that's my observation.
Any other comments? Where's the objection? This is zero draft, isn't it? They're looking for adoption. Just scoot. Go ahead, Jeffrey, at the mic.
Jeffrey, so I think I made a comment before. It still looks like to me that this is just using existing IGP fast reroute technique to calculate the backup path for to reach a particular BIER. It's basically the use of existing technologies to in the backup path calculation. If we need to explicitly spell that out in a draft, that's fine. But technology-wise, this seems to be an existing thing. Yeah.
There are three differences between unicast IGP micro loop avoidance. The first difference is the address used to calculate the PQ space. BIER use the BIER prefix of BIER, while unicast use the address of the destination node. The second difference is whether the method of establishing the repair list need to distinguish between for and for recovery. The third difference is that if multi-BIER have the same repair list, BIER can share the PQ nodes. They can establish a share tunnel. Thank you.
So in unicast case, you calculate the path and backup path to individual prefixes, for example, individual loopbacks. In the BIER case, you do the same thing. You calculate the path to individual BIER prefixes. And so you use basically the same way to same PQ concepts and then TLFA tunnels to make sure your backup path to a particular BIER does not cause loops. And then after those individual calculation, then you just put them into your fifth, and then you calculate FBM, and so that you can do the BIER forwarding magic. So if you break it down, it still seems to me that it's basically just using IGP backup calculation.
And as last observation, it's not really a loop, right? Because the bit will be extinguished. So what you will find is now our AD can provide input. What's the politically correct term these days for black? Nobody knows. So it's actually a black hole, yeah.
Any other comments?
Yeah.
Go ahead.
Yes, it is a short-term loop.
Any other comments about this draft? Looks like we got some feedback. Take it to the list, please. Any other comments about the meeting in general, the working group? Thoughts churned about the charter or milestones, missing comments? Wonderful. Have a great day in Vancouver. I guess I'll get in the line of cappuccino no matter who's there. Yeah,
No,
All right.
those lines, yeah, that's
it's
fine.
all there.
Your coffee and depraved. Yeah, okay, short and sweet.
Yeah.
Business done.
Yeah, we've cleaned up and eliminated noise and focus and started delivering. This is the IETF.
Yeah. As it used to be years ago.
Thank you, everybody. Have
All
a
right.
wonderful day.
Yeah, thanks for coming. Sorry? Today and tomorrow is already. Lunches, everything.
I got a reservation for 8 at 1.
I'm all booked up.
It's just so busy. He needs you. Not enough you to go around. You know, you feel sick.
It's tonight. Tomorrow I cannot joke. It's tonight. So there's one guy, Madison. You know him? Great guy. I want to go out with, but he attracting jobs. And the more you have jobs in, you get done shit done. But you talk shit. No, I already blew up bad last time. And you know, we kind of semi-friends and he had a divorce, you know. I told him, you are senior dean now. I gave, I helped you to get this promotion. I said, there are two things that are different from a dean.